Okay, 7.3 is on solving equations using what we call W substitutions. Okay, sometimes you hear these called quadratic type. So it says these types of equations always really look funny. Like if you look at some of the examples we have, like look at number 6, right? X plus 1 to the 5 over 2 plus 6 times x plus 1 to the 3 over 2. I mean, or 1/2. It looks very scary, doesn't it? Are you kind of panicking a little bit like, oh my god, how are we going to solve these? These are hard. Okay, we solve these by using a substitution method. Okay, so we're going to substitute another variable in, which is going to make it a lot easier. Okay, so the first thing that we're going to do is we're going to write things in descending power, and then we're going to pull out any common factors, and then we're going to look at usually the middle term. If we do factor by grouping, we look at the smallest degree. And we're going to rewrite it so it looks like a quadratic equation. So we're going to practice on these first 4 examples, just writing it with the W. And then on the next examples, we're going to actually solve the equations with W. Okay, so the very first one. So I have 2x to the 6th plus x cubed plus 9. Okay, so I'm going to look, it's already in descending power, right? 6, 3, none. So I'm going to look at the thing that's in the middle, the x cubed. And I'm going to replace it with a W. So I'm going to say let W equal x cubed. Just W, not W cubed. A lot of people think they just replace all of the letters with W's. Like that doesn't do anything. X's and W's would be the same, right? So W equals x cubed. Now think about it. If you square both sides, so if I take my x cubed and I square it, what's x cubed squared? X to the 6th, right? Do you guys see it? So now we can rewrite our expression with just w's. Okay, so I'm going to rewrite. So I have 2w squared, right? Because w squared was the same as x to the 6th, plus w plus 9. Okay, now it's in the quadratic form. So I could use the quadratic formula. I could try to factor. This one I don't think factors. Okay, so let's do number 2. So same idea. I'm going to look at that middle term, x to the 5th. And I'm going to replace it. I'm going to say let w equal x to the 5th. If I square both sides, w squared, x to the 5th squared, what do I get when I square x to the 5th? X to the 10th. You guys are very quiet today. You can talk. All right, x to the 10th. So I end up having 7w squared, right? X to the 10th was w squared, plus x to the 5th was w plus 6. So 7w squared plus w plus 6. Okay. The next one's, it's still in descending power, so we're good. Okay, I'm going to look at the thing in the middle. Now, when I look at the thing in the middle, I'm really just looking at the x part. I'm not worried about the number. That can always be like 2w, right? So I'm just worried about the x part. So I'm going to let my w equal x to the 1/3. What is w squared then? Audrey, what's w squared? No, 2/3, right? So 1/3 times 2 is going to be 2/3. I thought you were on it. I was like, I called you. I thought you were going to get it. All right, so I get x to the 2/3, and that's what I want. I want the first thing to be w squared. So I have w squared plus 2w minus 4. Okay, so now it's in quadratic form. Okay, now same thing on the next one. Like you could multiply that all out. You could do 3x minus 2 times itself, FOIL it out. That would be ridiculous. We don't want to do that. We're learning this new method for a reason. So what we do is we're going to let our w be the inside part. The w is the 3x minus 2 squared. Because now when I square both sides, right, if I have 3x minus 2 squared and then I square it, do you see how it's, yeah, 3x minus 2 to the 4th. That's what I want. So I replace and I get w to the 4th minus 5w squared, or sorry, what am I doing? W squared minus 5w plus 4. That's what I want. Okay, are you seeing how this works? So now that we know how to do this, we're going to go a step further. Okay, we're going to find what w is and then use that to find x. Okay, so number 1, it says x to the 4th minus 5x squared plus 4 equals 0. I know that you guys know how to factor this. I know that you guys know that you can do x squared and x squared -1 and -4, and then you can factor again, right? And you can get your 4 solutions, which are 1, -1, 2, and -2. I get that. You guys know how to do it, right? Yes? Say, yes, I know how to factor with x to the 4th, x squared and x squared. Right, we're going to do this example just so you can see how to do it with the W substitution. On your homework, if you run across something with x to the 4th, I don't care if you back it. Whatever way you want to do it. Okay, so what I'm going to do is I'm going to look at that inner term, the x squared. I'm going to let that be my W. So let W equal x squared. So when I square both sides, right, W squared is x to the 4th then. Okay, so now I can see what I'm going to replace each of the x parts with. So now when I replace, I get x to the 4th is now W squared. X squared is W. And then plus 4 equals 0. Do you know how to factor that? Yeah. W minus 4, W minus 1. So we end up getting W equals 4 and W equals 1. But we can't box in our answer yet. It's not all the way done. Because we've just solved for W, but our original problem didn't have any W's in it. It had X's. Okay, so now we have to replace. It's like you substitute in these twice. You substitute first with a W, and then you substitute back with an X. So what was W equal to? X squared. So now you put the x squared back in. See how it works? So once you find what W equals, put x squared back in. So now I have x squared equals 4, and x squared equals 1. So I can take the square root of both sides. I can do plus or minus, square root, plus or minus. So I end up getting x equals plus or minus 2, and x equals plus or minus 1. I get the same 4 answers that I would have gotten if I had just factored using x squared and x squared originally. Okay, so this is when people are like, well, why do we do this? Because sometimes we can't. Like sometimes you need to do it. Like sometimes it's not an x to the 4th. Okay, so let's try the next one. Same idea. So we're going to let W equal x squared. That way W squared is x to the 4th. And I don't mind if you don't write this W squared part, if you just know that it's going to be W squared. So I replace. So I have W squared minus 29W plus 100 equals 0. Does anybody know how to factor it? Good. Yeah, I don't know why, but it takes people a long time on this one. They're always like, wait, 10 and 10. Wait, they go through all of them and they forget the 25. All right, so I end up getting W equals 25 and W equals 4. So now that I have W, we go back and we replace. So I put my x's back in. So W was equal to x squared. So that means I have x squared equals 25 and x squared equals 4. So I take the square root of both sides, square root, plus or minus. Don't forget the plus or minus. Many of you guys forgot that on the semester 1 final. So I end up with x equals plus or minus 5 and x equals plus or minus 2. And all 4 of those are the solutions. Okay. It's a little weird. I get it. It's a little weird at first. Are you somewhat understanding it? Okay. All right, so let's do it with the weird fractions. Fractional exponents. First, check that it is in descending power, which it is, right? It starts out with 1/2, and 1/2 is bigger than 1/4. So we're looking at that thing that's in the middle. That's usually what our W is. So we're going to say let W equal x to the 1/4. So think about if I square it, if I have x to the 1/4 and I raise it to the 2, I multiply my powers, so I get 2/4, which is 1/2. So I have x to the 1/2 like I wanted. That allows me to see what each of the things is going to be replaced by. So my x to the 1/2 was my W squared. My x to the 1/4 was just plain W. Minus 6 equals 0. And I know how to factor that. So I have w minus 3, w plus 2. So I get w equals 3, and I get w equals negative 2. Okay, now I'm ready for the replacing step. I have what w is equal to. Now I plug back in. W is x to the 1/4, so I write that. X to the 1/4 equals 3. X to the 1/4 equals negative 2. Now I can tell right away one of them will not work. I want you to think about it. What does 1/4 mean? Like, what kind of root is it? Do you understand what I'm saying? 1/4. If I had a 1/2 power, what does that mean? Square root. If I have a 1/4 power, what does it mean? 4th root. So this is saying the 4th root of a number equals negative 2. It doesn't work. You can't take the 4th root of something and get a negative out. So right away, I know that I can cross out that one where it was equal to negative 2. But let's say I didn't know that. What if I went ahead and I solved it out? I'll show you what you will have to do then. Okay, so I have x to the 1/4 equals 3, and I want to get it to be x. So I'm going to raise both sides to the 4, right, to get rid of the 1/4 power. Do you see what I'm saying? Like when I raise it to the 4, this becomes x to the 1. And 3 to the 4th, do you guys know 3 to the 4th? 81. Okay, that one will work. But then the other one, when I raise this one to the 4th, I get x equals negative 2, raise to the 4th, I get x equals 16. What you should really do on W substitutions is check. And I know you guys hate checking. Like, I did all this work, why do I have to check it too? But here's what happens. If you check 81, it's okay. Because you have 81 to the 1/2 minus 81 to the 1/4 minus 6 equals 0. And you're seeing if that's true. 81 to the 1/2 means the square root of 81, which is 9. The next one is the 4th root of 81, which is 3. Does that work? Yeah. 9 minus 3 minus 6 is 0. That one works. So we circle that. But when you try 16, 16 to the 1/2 minus 16 to the 1/4 minus 6, you get 4 minus 2 minus 6. That doesn't equal 0, right? So 16 is out. So you can really, really save yourselves a lot of work if you see it right here. If you see, I have the 4th root of something equals a negative. There is no way for that to possibly happen, and then you just cross out that entire side. Okay, that way you wouldn't have to check. But if you don't do that, you're always going to have to check all of your answers. Kind of annoying. Okay, next up. Okay, this is one that has 4 pieces. This is going to be a factor by grouping one. So the first thing I'm going to do is I'm going to write it in descending power. In order to do that, it might help to get common denominators. Okay, so my x to the 1/2 is really x to the 3/6, right, if I change them all to 6. This next one is x to the 2/6. I'm going to subtract my 3x to the 1/6 over, and I'm going to add the 9 over. I'm going to get everything on one side. I have everything in descending powers, too. Do you see why this is a little bit different? It's not actually a quadratic. It's not going to end up being something squared, like w squared, because it has 4 terms. Okay, I can't look to the middle. There is no middle. There's 2 things in the middle. Yeah. Yeah, I subtracted this one over and I added this one over. Okay, so what I want you to do in this situation is I want you to look at the smallest power. So we're going to look at this x to the 1/6 part. That's going to be our w. So w is equal to x to the 1/6. Grant. All right, now what if I want x to the 2/6? How do I adjust my w? What do I do to both sides? I square it. So if I square both sides, x to the 1/6 squared, I get x to the 2/6. That's what I want. And how do I get x to the 3/6? I cube it, right? So this is going to involve also w cubed. That's why I said it's not really a quadratic. It's like a cubic function. There's something cubed. Okay, so I replace x to the 3/6 was w cubed. X to the 2/6 was w squared. X to the 1/6 was just our w. and we have plus 9. So how do I solve something like that? Factor by root 3. I'm going to split the middle. So I'm going to split it straight down the middle, and I'm going to pull out the common factors on the left. So I'm going to pull out a w squared. I'd have a w minus 3 left. Over here, I know I want to have w minus 3 left. So I can pull out a negative 3. Now I have a common factor of w minus 3. I factor that to the front. I'm left with w squared minus 3. So I get w equals 3, and then the other one's a little bit harder. I have w minus 3 equals 0. I'm going to add the 3 over. I'm going to take the square root of both sides, and I'm going to plus or minus. So I get w equals plus or minus the square root of 3. Grant. I'm sure that you all did not do this in Algebra 1. Did anybody do this in Algebra 1? New? It's pretty new, right? Pretty tough stuff. All right, so now I replace. So my w was equal to x to the 1/6. So I rewrite. So I have x to the 1/6 equals 3. X to the 1/6 equals root 3. And x to the 1/6 equals negative root 3. Okay, you can just cross out the negative root 3 one, because you have the 6th root. You have an even root equaling a negative, so that one's gone. You don't have to worry about it. Okay, how about this one? So I'm going to raise both sides to the 6th. So I'm going to have 3 to the 6th. Anybody know what that is? I would be very impressed if you did. 729. And then this one, raised to the 6th. You can use your calculator to help you. Or you can think of it this way. The square root of 3 is 3 to the 1/2. So I have the square root of 3 raised to the 6th. Right? 3 to the 3. What's 3 to the 3? 27. You guys know that one, right? So we get that. And those are your two answers. Okay, that's a long one. Those are hard. The factor by grouping ones. Okay, next one. This one's a little bit easier. Okay, this one, it's already in descending powers. It's like x to the 1, x to the 1/2, and so on. So we're going to let our w equal the square root of x. Never make it like 3 square root of x. It's just the x part. X to what a power. So I square both sides. So w squared equals x. So when I replace, I have w squared minus 3w minus 4 equals 0. And I can factor w minus 4, w plus 1. Are you stuck, Jonathan? Are you stuck on something? Oh, okay. So you get w equals 4, and you get w equals negative 1. Okay, now that you have w, you go back, you put in the x's. So w is equal to the square root of x. So you have the square root of x equals 4, and the square root of x equals negative 1. Okay, don't say it's 2. Everybody always does on the test. I always do a square root 1 on the test, and people are like, oh, I'll just take the square root. It's 2. What is x equal to? 16. You square both sides, right? Okay, what about this side? Square root of x equals negative 1. Nope. Nothing. We don't do it. You have the square root equaling a negative number. Remember, a square root has a sign in front of it. That sign that is in front of it is a positive. We call that the principal root. Do you guys remember this whole conversation, like chapter 5? It's already positive. And you say that a positive number equals a negative. It can't happen. So that's when we cross it out. If you had gone through and you had solved it, you would have had x equals 1. And when you check, you'd have 1 minus 3 times 1 minus 4. So you'd have 1 minus 3 minus 4 equaling 0. It doesn't work. So if you can recognize it from the root part, you're good, because you can avoid all of that extra work. So it just doesn't work. It's out. So 16 is your only answer. Okay, last one. This is hardest one. If you guys can do this, you can do everything on your homework. Okay, so we're going to rearrange everything. Okay, we want to get it in descending powers. So I have my 5 over 2, then I have a 1/2, and I have a 3 over 2. Do you guys see how the 3 over 2 needs to switch spots? So I'm going to have x plus 1 to the 5 over 2 minus 5 times x plus 1 to the 3 over 2 plus 6 times x plus 1 to the 1/2 equals 0. Okay, it's tricky. What do you think you're going to let your w be?
X plus 1
to the 1/2, right? Because then when you do that, do you see how you get the, how do you get the x plus 1 to the 3/2 then? It's w cubed. How do you get the x plus 1 to the 5/2? W to the 5th. So it's kind of a weird one, but it works out. So this becomes w to the 5th plus 6 w, or not, I'm writing it in the wrong order, aren't I? Minus 5 w cubed plus 6w equals 0. And we know how to solve something that looks like that. We pull out the GCF. My GCF is w. So I have w to the 4th minus 5w squared plus 6. And then you could do a w substitution again. Would not be terrible. In that case, you would use not w, but maybe like a new variable u. But we're not going to do that. If we have an x to the 4th, we actually know how to factor that. I'm not going to make you do w substitutions for anything that's x to the 4th. So in this case, if I have w to the 4th, I'm going to do w squared and w squared. I need them to multiply to be 6, but the outer and inner swoops need to combine to be -5. So I need a -2 and a -3. So I have 3 things, well, actually I have 5 things for w. I have w equals 0. I do my w squared minus 2 equals 0, so I get w squared equals 2. So w equals, when I take the square root, plus or minus the square root of 2. And the other one, w squared minus 3 equals 0, that gives you w equals plus or minus the square root of 3. So I have 5 possibilities for w. It's a lot. So I'm going to replace. I'm going to write it down here. So I'm going to say, let's start with the w equals 0. That means that x plus 1 to the 1/2 is equal to 0. Square both sides. Right, get rid of your 1/2 by squaring both sides. So I have x plus 1 equals 0. So I get x equals -1. That one will work. You can easily see if you go back to the beginning and you plug in -1s. -1, -1, -1. Do you guys see how all of them are 0? 0 plus 0 plus 0. Right, that one works. All right, then we try the square root of 2. So if I have w equals the square root of 2, I have x plus 1 to the 1/2 equals the square root of 2. Now, you could have done plus or minus square root of 2. It doesn't matter. When you square both sides, it's going to be positive. But really, like the negative ones, I just kind of leave off. Do you guys understand what I'm saying? Like, I don't put the negative root 2 because I have the square root equaling a negative square root. So I just kind of leave it off. But if you had done, so if you had left it on there, if I did a plus or minus, and then I square both sides, like raise both sides to the 2, when you square a negative, it's now positive. So you would get the same answer anyway. So you'd have x plus 1 equals 2. So x equals 1. That also will work. And then the last one, if I get x plus 1 to the 1/2 equals plus or minus the square root of 3. When I square both sides, I get x plus 1 equals 3, so I get x equals 2. And I believe all 3 of those work. Okay, you can check them and see if they work.